In this video, we will generate a dataset of cosine Wx, where the W is the wavelength factor, which varies from 0.66 to 1.5. So data validation, list of items from 0.666 to 1.5. So that is from 0.66 to 1.5. Likewise, for the G, which is the same value, so data validation, list of items, again this is from 0.66 to 1.5, so we can start from 0.666. Now the data set of cosine are a formula: cosine W times X, so W times X. Now the Maclaurin series expansion, which is the summation of a times x to the power 2n, where the value of n is from 0 to infinity, and the value of a is equal to our array formula minus 1 raised to the power n times g raised to the power 2n, so g raised to the power 2 times n, divided by, so that's the numerator. Now the denominator, that is factorial 2 times n. Now we can complete the Maclaurin series expansion of the cosine. So this is equal to our formula, SERIESSUM of the x values raised to the power 2n. 2n starts from 0, incremented by 2, and the coefficient a will be this range. And we'll chart this. Insert chart, and we use scatter chart. Column A as label, and we don't need the title because we need a space. For the series, show the trend line. The type, polynomial. The degree, 8. For the label, use the equation. For the legend, position at the bottom. So here's our trend line and polynomial of cosine Wx. And we'll calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power. This is equal to transpose 0 to 8. And the elements of the matrix are a formula of the x values raised to the power 0 to 8. Now we can calculate the polynomial regression coefficient using LINEST. Data y, comma, data x. This is also LINEST. Data y, comma, data x. And let's compare our polynomial regression coefficients against the chart. X to the 0, that's 1. Coefficient of x, that's 0.0016, that's 1.67 times 10 to the minus 3. Coefficient of x squared, negative 0.226. Coefficient of x cubed, 5.14 times 10 to the minus 3. Coefficient of x to the 4th, 5.16 times 10 to the minus 3. Coefficient of x to the 5th, 1.06 times 10 to the minus 3. Coefficient of x to the 6th, 3.46 times 10 to the minus 4. Coefficient of x to the 7th, 2.79 times 10 to the minus 5. And coefficient of x to the 8th, 7.35 times 10 to the minus 7. Suppose I change the wavelength factor to 0.8. I will change this also to 0.8. Now they're the same. The values are exactly the same. Change this W to 1. That's cosine x. Also, I have to change this to 1. And it's also cosine x. Now increase the frequency a bit. 1.25. 1.25. Now you have a shorter wavelength. So from here to here, that's shorter wavelength. You increase the frequency to slightly to 1.5. Now the frequencies change slightly and the wavelength gets shorter. This completes the use of Taylor-Maclaurin series sum expansion and LINEST polynomial regression of cosine for varying wavelengths.